this video, I'm going to show you how to multiply binomials. So first of all, we want to multiply x plus 3 times x plus 4. Now there's one way to do this that's very tempting, but incorrect. And that tempting but incorrect way is just to multiply x by x to get x squared, and then 3 times 4 to get 12. So again, this is tempting, but it's not correct. To see why it's not correct, just set x equal to some value like 1. If x equals 1, then we have x plus 3 times x plus 4 becomes 1 plus 3 times 1 plus 4, which is just 4 times 5, which is 20. But if we use this rule, x squared plus 12, we get 1 squared plus 12, which is just 1 plus 12, which is 13. And these are not equal, which means these two expressions surely cannot be equivalent. Okay, so now we know the incorrect way to multiply these. Why don't we talk about the correct way, which uses the distributive property. To illustrate this, let's use some color. So let's write this again. X plus 3 in blue times x plus 4 in green. Now applying the distributive property, we have that the sum x plus 3 times this binomial is equal to x times that binomial x plus 4 plus 3 times that same binomial x plus 4. And now we can go ahead and multiply through. So this becomes x times x, which is x squared, and then plus x times 4, which is 4x, and then plus 3 times x, which is 3x, and then plus 3 times 4, which is 12. Now combining like terms, this 4x and this 3x, we have x squared plus 7x plus 12. So this is the correct result here. X squared plus 7x plus 12 is what we get when we multiply these binomials. We can even check it with x equals 1 just to make sure. When x equals 1, then x squared plus 7x plus 12 becomes 1 squared plus 7 times 1 plus 12, which becomes 1 plus 7 plus 12, so 8 plus 12, which is 20. And there we go. These match up nicely, so that works out. Now that we know how to multiply binomials, why don't we go ahead and do some more exercises. So multiply x plus 2 times x plus 3. Again, we just use the distributive property, so each term in this x plus 2 multiplies this binomial here. So we have x times that binomial, x minus 3, and then plus 2 times that binomial, x minus 3. And now we can go ahead and distribute the x through this binomial. So x times x makes x squared, and then minus x times 3, so minus 3x, and then plus 2 times x is 2x, and then minus 2 times 3, so minus 6. Now we combine like terms. X squared, negative 3x plus 2x makes negative 1x, so just negative x, and then minus 6. So there we go. There's our result. Alright, on to the next one. 3x plus 5 times 4x minus 1. Again, we just go ahead and multiply each of these terms over to the other binomial. So 3x times 4x minus 1, and then plus 5 times 4x minus 1. Go ahead and distribute the 3x across, so 3x times 4x makes 12x squared, then minus 3x times 1, so just minus 3x, then plus 5 times 4x, so plus 20x, minus 5 times 1, so minus 5. Alright, so combining like terms, we have 12x squared, then this 20x minus 3x makes 17x, and then minus 5. Alright, here's another one. Multiply x plus 4 times x minus 4. Alright, so again, we'll just go ahead and distribute. So we have x times x minus 4, and then plus 4 times x minus 4. X times x makes x squared. X times minus 4 makes minus 4x, and then plus 4 times x, so plus 4x, and then 4 times negative 4, negative 16, so minus 16. Combine like terms, we get x squared, and this minus 4 plus 4, these cancel each other out. They go to 0, so just x squared minus 16. And there's our result. Do you notice anything peculiar about this result? Well, it's exactly what we get if we just multiply x times x to x squared and 4 times negative 4 to negative 16. Of course, we know that's not the correct way to multiply binomials in general, but for some special kinds of products like this, it does work out. Let's investigate that a little bit more. Suppose we have a binomial a plus b, and we multiply that by another binomial, a minus b. Let's go ahead and do the distribution here. So a times a minus b, and then plus b times a minus b. So that makes a times a is a squared, and then a times negative b makes negative ab, and then plus b times a makes ba, and then b times negative b makes minus b squared. Alright, now let's go ahead and rewrite these middle terms. So this time we'll write a squared minus ab plus, instead of writing ba, we'll write ab, because that's equivalent. Multiplication is commutative, so you can just switch it around like that. Okay, so that's minus b squared, and then we see that these middle terms cancel. Minus ab plus ab, these cancel out. So we just have a squared and then minus b squared. So we do have a nice general rule. Whenever we are multiplying binomials of the form a plus b, a minus b, then we do get a squared minus b squared. Let's apply that general rule from the previous slide to solve these problems. So again, remember that if we have a plus b, that binomial, times a minus b, then the result is a squared minus b squared. Now in this problem, multiply the binomial 3x plus 2y by the binomial 3x minus 2y fits into this template perfectly. A is 3x, and b is 2y. Let's write that down over here. A equals 3x, b equals 2y. So the result is a squared minus b squared. A squared, a is 3x, that becomes 3x squared, and then minus b squared. So minus b is 2y, so minus 2y squared. 3x squared is just 3 squared times x squared, so 9x squared, and then minus 2y squared, and 2y squared is just 2 squared times y squared, so minus 4y squared. So there we go. There is our result. Okay, next problem. X squared minus 5y times x squared plus 5y. So again, we're going to refer back to the rule that we have. A plus b times a minus b equals a squared minus b squared. This problem has the minus coming first, but that's okay because these are just two terms multiplied together. So multiplication is commutative and we can switch them around. So we can write that a minus b times a plus b is still equal to a squared minus b squared. Now matching up with our problem here, a is just x squared, and b is just 5y. So then a squared minus b squared becomes, well, a squared is x squared, that squared, and then minus b squared, so minus 5y squared. Alright, so what is x squared squared? Well, when you raise an exponentiated expression to an exponent, you multiply the exponents. So that's equal to x to the 2 times 2, or just x to the 4th. And then minus 5y squared, so minus 5 squared y squared, which means minus 25y squared. And there we go. There is our final result. Now we know how to multiply binomials. And in the future, we'll also learn how to multiply not just binomials, but also polynomials.